Hey guys, so in this week's video we're going to be doing the 2022 AIME I Problem 10. The problem states that three spheres with radii 11, 13, and 19 are mutually externally tangent. A plane intersects the spheres in three congruent circles centered at A, B, and C respectively. And the centers of the spheres all lie on the same side of this plane. Suppose that AB squared equals 560, find AC squared. So first, let's just make sense of this problem. We have three spheres of varying sizes, and we have a plane that intersects all three spheres. So if we kind of draw like some sort of, 2D representation, we're gonna have something that looks like, well, from a bird's eye view, this would look like we would have three congruent circles. So this is from a bird's eye view, and they're congruent because we're given that the plane intersects the spheres in three congruent circles, and this will be, say, A, B, C, and we're given that AB is, the square root of 560. Well, this initial diagram that we've drawn isn't very helpful because, well, we don't really have an easy way to use our the other information, which is the radii of the three spheres. So let's see if we can do something else. So instead of doing a bird's eye view, which is basically perpendicular to the plane, we should actually take a cross section that passes through two of the circles at once. And so that's basically parallel to the plane, or not really parallel, but since we only have, since we're taking a cross section, we're going to only see basically one line of the plane. So what that would look like is, well, let's say we take the cross section that passes through circles A and B first. So what that would look like would be, we have circle like this with radii 11, and then a second circle with radii 13, like that. And let's say, well, let's call this circle center. So this would be the same as this one, but since A is the center of the circle that is formed by the intersection of the plane and the sphere, let's just call this center of the sphere itself A prime. And this would be B prime. So we're basically looking at these two spheres right now. So what do we know? Well, if we draw a plane, let's say it looks something like this. Well, let's say that let's just draw perpendiculars from the centers of the circle to this, the intersection with the plane. So here and here. Well, we know that these are perpendicular because the radius is always perpendicular to any chord. And we know that this length here is equal to this length here, because this is the circle that is formed from the intersection of the plane with the sphere, and we're given that they're congruent. Okay, so what do we know about this length? This length is going to be 11 plus 13. So A prime B prime is equal to 24. And let's just call these lengths RA, R sub A, and R sub B. Because we don't really know what they are, so let's just assign variables. Well, we know that this length here, these are going to be points A and B. AB is equal to, AB squared is 560. So since this is squared, that implies that we might have to use a Pythagorean theorem somewhere, and that's exactly what we have to do. Because if we drop a perpendicular from here to here, what do we get? We get that this length is going to be equal to AB, because we've basically constructed a rectangle. So this is root 560, and this is going to be 24, as we said earlier. So if we use the Pythagorean theorem to solve for this length here, well, we get that 24 squared is 576, 576 minus 560 is 16, square root of 16 is 4, so this length here is 4. So what does this tell us about the relationship between RA and RB? Well, we get that RB is RA plus 4. Because we can, from the same logic as we said, this is a rectangle. So if this is RA, this length here must also be RA. And that's how we get this first equation. Now we can do a similar thing for the other two circles. So now let's look at these two circles, A and C, or spheres, I guess. So let's just draw the same diagram. So this is 11 and 19. Draw this plane, and we get this is going to be A, and this will be C. And just remember that we're actually trying to solve for this length here, AC squared. So this, again, this is called this R sub A, and this will be R sub C. Now we can similarly get another equation relating these two lengths. So if we drop this perpendicular here, we get that AC squared plus, I guess, RC minus RA, because this length here is RC minus RA. So C minus RA squared is equal to 900, which is 30 squared. All right, and we can also do this one more time for our last pair of circles, B and C. So from that we get BC squared plus RC minus RB is equal to, squared is equal to, it'll be 32 squared. I'm not really sure what that is, so I'll just write 32 squared. Okay. Now what we can do is, well, we have a system of 3 equations, but we actually have 4 variables, RB, RA, RC, actually 5 variables, I guess. So we're not going to be able to solve this. What we can do is use the fact that all 3 of these, I guess, these lengths here are all going to be equal. So point A to this point here, point B to this point here, similarly A to this point here, C to this point here. I didn't really draw it properly, but they're equal because the problem says that these circles, which are formed by the intersection of the plane with the sphere, are congruent. So let's just call this length, well actually no, we know that this length is equal to 11. So let's call this length here the radius of all 3 congruent circles, x. What do we get? Using Pythagorean theorem again, we get RA squared plus x squared is equal to this length squared. But we know that this length is the radii of circle A. So we know that that's going to be 11, so 121. Sorry, 121. And we can do this again for the other 2 circles. So we get RB squared plus x squared is going to be 169. can do this for RC squared, so 19 squared. Okay, now we definitely have enough equations to solve for all of the variables. So let's just choose which ones are easiest. So we have, let's look at these two equations first. If we subtract these two equations, we get RB squared minus RA squared is 48. And we also know that RB is equal to RA plus 4. So now we can solve for RB and RA. And I'm just going to skip the math part, but we'll get that RA is equal to 4 and RB is equal to 8. Okay, now we can solve for x if we want, because then we can use x to solve for RC, right? So if we plug in R equals 4, we get x squared is equal to 105, which means RC squared is equal to 19 squared minus 105. And this, well, 19 squared is, this would be 81, 17, 9, 1, 361. If we subtract 105, we get 256, which is 16 squared, so RC is equal to 16. Okay, now that we know that RC is equal to 16, and we also have the values for RA and RB, we can solve this equation for AC squared, which is what we want to find. So RC minus RA is 12. 12 squared is 144. 900 minus 144 is 756, which is what AC squared is equal to. So the answer is 756.